All right, this is coding problem set 5, the cipher and object-oriented programming. So for problem 1, we need to fill in the build shift dictionary method and the apply shift method according to the comments in the code or their description in the code. So for the build shift dictionary method, we want to create a dictionary that can be used to apply a cipher to a letter. The dictionary maps every uppercase letter to a character and shifted down the alphabet by the input shift. The dictionary should have 52 keys of all uppercase letters and all the lowercase letters only. So to get started, we have um, letters equals string.ascii lower, so we can get the lowercase letters and store them in string. Then we concatenate the lowercase letters to handle wraparound. So we have letters shifted equals letters times 2, shift colon shift plus 26. Next, we need to add the uppercase letters. Um, we do that by saying letters equals letters plus letters upper, or the uppercase letters. Basically, just add them to letters. And then we do the same thing we did with the lowercase letters here to here. We do that to the uppercase letters. We have letters shifted plus letters shifted dot upper. Next, we initialize our shift dictionary and we create a loop that'll iterate through 52 times through all the letters and essentially add them to the dictionary and associate them with their shifted counterpart. Then we return the shifted dictionary. The next method that we need to do is the apply shift. In this, we apply the Caesar cipher to the self.message text with the input shift. It wants us to do it by creating a new string that is self.message underscore text and shifted down the alphabet by the same number of characters determined by the input shift. So we do that by first initializing a list to store the characters in the decrypted message. We initialize it as a shorthand new message equals an empty list. Next, we have a for loop that iterates through each character in the message. And inside the for loop, we have an if statement that checks if the character is not in the shifted dictionary. So if I not in self.build shifted dictionary, we use the build shift dictionary call dot keys. And if I is not in this, then we have a declare new message dot append, and we append the character. Next, we have the else statement, which is states that if it's present, then we append the corresponding character after shifting it. So we do that by new message.append self.build shift dictionary shift and then at position I or parentheses shift, then we at position I. Then we return the decrypted message as a string. So return string dot join new message. Our next, we have problem 2, plain text message. So it says here for this problem, plain text message is a subclass of message and has some methods to encode a string using the specified shift value. Our class will always create an encoded version of this message and will have the methods changing the encoding. And it wants us to implement the methods of the plain text message. according to their description in the code. So these methods, all right, so it's talking about these methods. So first we do init.shift self-text shift. So this is our first method. In this method, we want to initialize a plain text object. Um, and we want it to have these attributes. So first, in order to do this, we set the shift attribute to the provided shift value. So self.shift equals shift. Next, we set the message text to, or set the message text attribute to the provided message text. So self.message text equals text. Finally, or next, we load the list of valid words from the file. Um, words.txt is the actual file. It's in the directory for this. And we use word list underscore file name as kind of a placeholder. So we have self.validWords equals load words, word parentheses word list file name. Next, we want to use the build shift dictionary method from the parent class to create um, the encrypted dictionary um, and set it to create a dictionary. So we have self.encrypt underscore dictionary on self.encryptdict equals super, which accesses the um, parent class from the subclass, or we use it in the subclass to access the parent class. So we're accessing the parent class plain text message. And we next we do dot build shift dictionary and call the build shift dictionary with the parameter of shift. Um, and run this function onto this command. Um, Finally, we want to encrypt the message using the apply shift method of the parent class. Then we want to set the message text encrypted to the encrypted message. So we do that by saying self.message underscore text underscore encrypted equals super, which accesses the plain text message parent class dot apply shift. We call the apply shift function and use the parameter shift. Next, we want to do the get shift method. So in this, we simply want this method to, or you want to use this method to safely access the self.shift outside the class. So we basically just say return.self.shift to do this. And for the next few methods, we do pretty much similar steps. So for the get encrypted dictionary self, we want to use this method to safely access a copy of self dot encrypting dictionary. And we want to pull it or use it outside the class. So in order to do that, we say encrypting dictionary copy, or we initialize the variable encrypting dictionary copy and make a copy of the list to set this equal to, or make a copy of self dot encrypting dictionary, make a copy of the dictionary and set it equal to this variable. Next, we just simply return the copy. Next, we get message text, or get message text underscore or encrypted using the parameter self. We simply take this method and return it. Next, we have the change shift function. So we do this by, or the parameters for this are change self dot shift of the plain text message updates the other attributes determined by the shift, i.e. the self.encrypting dictionary and the message text encrypted functions. And, and we want it to return nothing. So we start this code by setting the shift attribute to the provided shift value. So self.shift equals shift. Next, we want to update encrypting dict with new shift values. We do that by saying self.encrypting dictionary equals super, which accessing the plain text message, um, plain text message parent class dot build shift dictionary shift, and we want to, and then after that, we want to apply the encryption and update message text encrypted. So we have self.message text encrypted equals access the parent using parameters of parent class dot apply shift function call. Yeah. Um, see, that was the change shift method. Change shift. Next, we move on to problem 3. For this, as it says here, for this problem, um, given an encrypted message, if you know the shift used to encode the message, decoding it is trivial. If message is the encrypted message and S is the shift used to decrypt the message, then apply shift gives you the original text message. Um, for this problem, we want to fill in the methods of the cipher text message class according to their specifications in the code. So it's um, these methods. So I'm gonna go. So we start this class, and then this is the message or the method of it for the class. So in this, we need to initialize a cipher text message object. Um, a cipher text message object has two attributes: self message text, which is a string determined by the input text, and self.valid words, which is a list and is a helper function, and uses the helper function load words. So first we want to simply set the message text attribute to the provided message text. So we just do that by saying self.message underscore text equals text, and we then want to load the list of words from a specified file, which in our case is the words.txt file, but we use word list underscore file name as somewhat of a placeholder for until this is called, or well, word list file. If I remember correctly, anyway, where was I? Yeah, we set it equal to self.valid words equals load words with the word list underscore file name parameter to load the words from words.txt. And so our next function is the decrypt, or our next method is the decrypt message method. So for this, we want to decrypt the self.message text by trying every possible shift value and find the best one. The best one in this case is the one that has the most valid words in it after applying the shift method or the decryption method, or after applying the Caesar cipher shift or the cipher shift to it. So it returns a tuple of the best shift value used to decrypt the message and decrypt the message text using a shift and the decrypted message that's using that shift value. So first we want to initialize the best shift value. This is basically the value that or the value that we use for the shift cipher that has that yields the most amount of valid words. We initialize that and set the variable equal to 0. Next, we initialize the maximum real words variable um, that we can use to keep track of the most or keep track of the real world or keep track of which decryptions had the most real world words. Next, we have the best message, which we just store as a empty string. So next onto our code, we have to iterate through all the possible shift values. So for S in range of 26, since there are 26 possible different shift values that it could be. Um, Next, after that, we need to decrypt the text. We need to decrypt the text, or decrypt the message with the current shift. We do that by saying decrypt underscore text equals self dot apply shift. Call the apply shift method with the parameter of s or the position s, or my mistake, using the s as the variable of shift in this method. Next, we want to split the decrypted text into words. This is basically so that we can have a list of words to call from, a list of words to iterate through and manipulate. So we have this list words and decrypted text dot split, which splits the whole message into individual words into a that can be stored into a list. Next, we want to count the real words in the decrypted text after we apply the shift method. We do that by saying the variable real words equals a sum of function call is word self dot get valid or self dot get valid words um, with parameter or is word with parameter self dot get valid words comma w, and we do that for every w in words or every element in words. Next, we update if the current shift procedure um, if the current shift procedure has more real words in it compared to the previous one. So we say if words is greater than max real words, then we set the position or the value of the shift. Um, we we store that in the value of the shift into best shift and update the value as we go through the list. Next, we set the amount of real words or the amount of maximum words that we found equal to real words. And basically just update the count of real words in the message. And we store the decrypted text into the best message variable as a string. Finally, after we finish iterating through the for loop, we come down here and we simply return the best shift value in the decrypted message. So next we have problem 6, where we just need to, or problem 4, where we just need to decrypt the story. In this, now that you have all the pieces in place, please use the story.txt file to decode the story. The PS or our given code contains helper functions such as get story string that returns the encrypted version of the story, as a string, and we want to create a ciphertext message object using the story string to in order to decrypt the message to return it to return the appropriate shift value of the unencrypted story. So after these examples, we have this, where we have our function decrypt story. Should be so we have just this variable joke code or story code, um, which is which is um, which is used to store the ciphertext message object. In this, we do get story string, and basically we get the story and store it as the story as a ciphertext message, and store it into joke code. Next, we have our story, which is equal to joke code dot decrypt message. And finally, we return the story, or we store the we call the decrypt message function and apply it to the what we've applied to our ciphertext message object or joke code, and we store this into the story variable string, and then we just return the story, and then we can print the then next we can just call this function right after that, and then we can print it. So I'm going to go ahead and run the code. As you see here, it gives a fully coherent decrypted story using the cipher shift of 16, and all the other test example functions work as well. So this concludes my coding problem set 5 cipher and object-oriented coding.